Hi class. Today we are going to focus on our next section, which continues factoring trinomials, section 6.3. Okay, so remember from our last section that when we multiply many binomials together, the result is often a trinomial. And this, once again, is because we can combine the middle term to become a single middle term, right? In this case, negative 10x plus 3x gives us a negative 7x. Now, you may notice something else about this picture here. In the previous examples, we focused on a single x squared. But in this example, we have 2x squared. Or what if we had 5x squared? Or what about negative 3x squared? These become a little bit more tricky, but the technique is going to remain very similar as what we have done with our scenario where it was 1x squared. So we always focus on 1x squared because it's a little easier. We can get comfortable with that. And now we move on to it being a more tricky trinomial. Okay, so we're now going to look at these trinomials that look like ax squared plus bx plus c. A, b, and c are just numbers. They're just placeholders. So we're just going to have a number times x squared, a number times x, and a constant term. And in our previous, again, what we did was we just let a be 1. Now we're going to let a be whatever it wants to be. Okay, so let's look at an example. The best way to learn is by kind of convincing yourself that one example works, and then we want to create a step-by-step technique to mimic that example, right? This is a lot of mathematics. We go through and we go, how did you do this one? Well, if I want to do this one, I should do it very similar to how we did the first one. So let's look at this example. 3x squared minus 20x plus 28. The trick we will use is once again to rewrite the middle term. Okay, so that's what we did last time. So you're going, oh, Dr. J, we did this already, right? Perfect. Okay, so let's rewrite the middle term. What's our middle term? Minus 20x. I'm going to rewrite it as minus 6x minus 14x. Perfect. Minus 6 minus 14 gives minus 20. Okay, so now I rewrite my trinomial as a polynomial with 4 terms. And what do you think I'm going to do? Factor by grouping, right? Okay, so we group. We can pull out our greatest common factor. We have our binomial. I group. Remember, first term negative, pull out a negative. And then I have my common binomials here, and I pull out my common binomial. Boom, that wasn't so hard, right? We turned the trinomial into a factored form of 2 binomials. The question is always, how do we know how to split? Well, last time we focused on this number, but we didn't have a number here. Okay, so how do we account for that new number? Okay, so the trick to making these problems work is splitting the middle term. To find the correct way to split the middle term, we once again use what we call the AC method. Okay, and let's click back. Why do you think we use the AC method? What stands out here? A and C. Notice the first and last terms. Okay? That's why it's called the AC method. First and last terms, right there. Okay, so this method works by finding a pair of numbers that multiply to a certain number and add to another number, okay? So what we want to do is we want to multiply to get AC. This is why it's called the AC method. We multiply to get AC, and then we add to get B. Remember in our previous section, A was 1. So we had just the special case where we're just focusing on the constant term. That's why we just said, look at the middle and last terms. But now we have to account for that first term, okay? Okay, so let's look at another example. 6y squared plus 7y minus 24. So we still want to focus on the middle term, our 7, right? But now we want to focus on the first and last. So let's multiply. 6 times negative 24 is negative 144. Okay, we want to find a pair of numbers that multiply to negative 144 and add to positive 7. Okay, this one's going to be a little more tricky because, well, now I have to find all of the factors of 144. And then to get a negative, I have to remember that one of the factors has to be negative. Now, without listing out all of the factors of 144, I would pause the video and try to find all of the factors of 144, and then convince yourself by making one of them negative that the pair that works is 16 and negative 9. Notice that 16 times negative 9 is negative 144, and 16 minus 9 is positive 7. So that's our magic pair. Okay, so I'm going to split my middle term. So 7 now becomes 16 minus 9. Now I factor by grouping. Okay, so I group, and then I group. And I'm going to let you pause the video and look and convince yourself that this is how I group. And then I notice my common binomial that I can factor out, creating my factored form. Okay, now I have a product of binomials. Okay, after pausing the video and looking more in detail at that last example, we should notice a couple of things. First, the A times C multiplication potentially makes our number larger, right? In this last example, it sure did. This makes it difficult to find factors, right? We're going to probably need our calculator with us to be able to trial and error some division so we can list all of the factors of these numbers. 2, the numbers we use to split the middle do not necessarily show up in our factored form. And we can see that from this last example. Notice we use 16 and negative 9. 16 and negative 9 don't even show up in here, right? So there's not really a kind of cheat move here for these problems. But finally, the good thing is we should notice that it is the same process, just a tad bit more difficult, okay? Okay, what I'm going to do now is make this method a little nicer so we can utilize some of our tricks from the previous section. And this is called the bottoms up method. And I learned this actually a couple years ago when I was teaching this class. A student showed me. I have never seen this method before, and a student showed me this method, and I've used it ever since. It's a very nice method. Here, it's called the bottoms up method. Okay, so let's look at this trinomial. 3x squared plus 10x plus 8. What we're going to do is we're going to still start by multiplying our A and C, our first and last. Okay, so when we do this, we notice first times last, 3 times 8 is 24. If we look at all of the pairs of 24 here, that give us 24 to multiply. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Good. Okay, now what I want to do is I want to still, once again, focus on my 10. I want a pair that adds to 10. Well, we go 4 and 6 add to 10. So let's choose that pair. Okay. So naively, this is where the trick comes in. Naively, we go, hey, let's do it like we did before. X plus 4, x plus 6, right? Because 4 and 6 are the numbers we use. Well, obviously, this is not our answer because this would give us an x squared, and our previous problem has a 3x squared, right? So this is our naive solution, saying let's use our previous methods. Okay, now here's where the bottoms up trick comes in. What was our A? If we go back, we remember that our A was 3, our first term. I'm going to use that now. So what I'm going to do is I'm going to take each of these numbers and divide by 3, my A. And I'm going to simplify. I'm going to simplify by dividing, or I'm going to simplify by reducing, because they're both fractions. 4 divided by 3, that can't be reduced, so I'm going to leave that. But 6 divided by 3, that divides nicely. So that's 2. So now I have x plus 4/3, x plus 2. Here's where the name comes in. Anything that didn't divide nicely after simplifying, that stays on the bottom, we're going to bring it up to the top here, up to the front. And this is why we call it the bottoms up method, because I'm going to bring my bottom up. So x plus 4/3 is going to turn into 3x plus 4. And the x plus 2, there was nothing left on the bottom, so I don't have to worry about it. And this is my final answer. And you can check by foiling here, if you want to pause the video and foil this. Okay, so this is going to be our trick for the AC method. Okay, let's look at another example. We should pause the video for a second. We should notice something here. Okay, so after pausing the video and looking at this trinomial, we notice what? That there's a greatest common factor, right? Again, we want to always look at a polynomial, and step number 1, is there a greatest common factor? And in this case, there is. So we want to factor that out. What else do we notice about this trinomial? The first term is negative. What do we always do when the first term is negative? We pull out the negative with the greatest common factor, okay? So the greatest common factor is 3y, but because the first term is negative, we're going to make it a negative 3y. And now what's our leftover after division? 3y squared minus 13y plus 4. So now we have a new trinomial. So I'm going to use my tricks. Okay, my AC method, my first, last. Multiply, I get 12. So I want to look for factors of 12 that add to negative 13. Okay, if we list all of our factors of 12, 1 and 12, negative 1, negative 12, 2 and 6, negative 2, negative 6, 3 and 4, negative 3 and negative 4, which ones add to negative 13? This one, right? Negative 1 and negative 12 give us a negative 13. So that's how we factor. Remember, the trick is we go use negative 1, use negative 12. Okay, but we have to remember the bottoms up method. So now I'm going to take my A. Remember, my A was 3. So I'm going to divide each of these terms by 3. I'm going to simplify by dividing or reducing. This one doesn't reduce. This one divides nicely. And then anything left on the bottom, I'm going to bring up to the front. So I'm going to bring that up to the front, and here's my factored form of the trinomial. Putting this all together, this trinomial factors as my greatest common factor, and then my 2 binomials that I created from factoring my trinomial. Okay, if you need to, go back through these 2 videos You can watch them as many times as you want. Please reach out to me through email if you need, or reach out to our math fellow. Two great resources to learn this material.